Now in this video, we're going to talk about the graphs of the tangent and cotangent functions, y equals tan x and y equals cotangent of x. So I'll start out with the graph of the tangent function, and we're going to do this the same way we did the graphs of sine and cosine. We're going to look at some of our common angles that we know the trig values of. We're going to find, in this case, the tangent values, reminding ourselves that tangent is sine over cosine. So here I've done values of x, angles ranging from 0 to 2 pi in increments of pi over 4. Wrote down the sine and cosine values. And then if we take sine over cosine, we get tangent. Okay, so doing that, when x is 0, tangent is 0 over 1, which is 0. When x is pi over 4, sine over cosine is 1 over root 2 divided by 1 over root 2 is 1. When x is pi over 2, tangent would be 1 divided by 0, which is undefined. When x is 3 pi over 4, sine over cosine is 1 over root 2 divided by negative 1 over root 2 is negative 1. When x is pi, sine over cosine is 0 over negative 1 is 0. When x is 5 pi over 4, sine over cosine is 1. When x is 3 pi over 2, sine over cosine is again undefined. When x is 7 pi over 4, sine over cosine will be negative 1. And finally, when x is 2 pi, sine over cosine will be 0 again. Okay, so what we're going to end up with is something that looks like this. So our graph will start at the origin, x is 0, y is 0. We're going to have a point at pi over 4 comma 1. At x equals pi over 2, since we have something that looks like 1 over 0, this would be kind of like the graph of 1 over x, if you know that graph from algebra class. The graph of 1 over x at x equals 0. Okay, so what's going to happen here is we'll have a vertical asymptote at x equals pi over 2. Okay, so that indicates that our function graph is either going to go up to infinity or go down to minus infinity as we approach pi over 2. At x equals 3 pi over 4, we have y equals negative 1. At x equals pi, y is 0. When x is 5 pi over 4, y is going to be 1. When x is 3 pi over 2, we're undefined. We're going to have another vertical asymptote. Okay, when x is 7 pi over 4, y is going to be negative 1. When x is 2 pi, y is going to be 0 again. Okay, and we'll also step this backward a little bit, just to make our graph a little more complete. The angle negative pi over 4 is coterminal with 7 pi over 4. Okay, so there y will be negative 1. And negative pi over 2 is coterminal with 3 pi over 2. So we're going to have another vertical asymptote there. Okay, so now we'll connect the dots. So connecting the dots, we start out with something like this. Okay, and then we note that as our angle increases and approaches pi over 2, what's going to happen? Well, the sine values are going to be approaching 1. So again, we're increasing our angles between, let's say, pi over 4 to pi over 2. So our sine values are going to increase to 1. Our cosine values are going to stay positive, but they're going to decrease to 0. So the tangent values, again, we're in the first quadrant, so we could find this that way as well. Our tangent values are always going to be positive, but they're going to be tending towards something that's undefined. They're going to be going off to infinity. And since those tangent values are always positive, that tells us that our tangent values will go up to positive infinity. Okay, so our tangent values are going to blow up that way. Moving to the right of that first asymptote. So again, I'll connect the dots here. Now if we look at this little bit between pi over 2 and 3 pi over 4, so now we're in this zone. Between the angles pi over 2 and 3 pi over 4, here our tangent values are going to be negative because now we're in the third quadrant. Or sorry, in the second quadrant, I should say. We're in the second quadrant between pi over 2 and 3 pi over 4. And in the second quadrant, tangent values are negative. Therefore, as we approach the angle pi over 2 from the right, those tangent values will go to minus infinity. And then between 5 pi over 4 and 3 pi over 2, now we're in the third quadrant where tangent values are positive again, so we're going to approach plus infinity because those tangent values are positive. And then here we're going to be in the fourth quadrant where tangent values are negative again, so we're going to be approaching minus infinity, and then we can continue this. And then over here, we're back in the fourth quadrant. We're going to be approaching minus infinity. Okay, so this is the graph of the tangent function. Okay, so a couple things we want to note looking at this graph. First off, unlike the sine and cosine function, the domain is going to be all x except the odd multiples of pi over 2. Okay, because now we can't have any x values where the cosine of x is equal to 0, because then the tangent will be undefined. Okay, so the graph here has vertical asymptotes, which we didn't have to worry about with the sine and cosine graphs. Note that the range is all real numbers. And because every single y value is accounted for in this graph. This is different from the sine and cosine graph where the y value is only ranged from -1 to +1. Here, every single y value is accounted for in this graph. Okay, note that the tangent graph is periodic, but unlike sine and cosine, the period is going to be pi. So this is a tricky thing to get a handle on, but note that, for example, this yellow box denotes one full period of the tangent graph, and that's going to run between -pi over 2 to pi over 2. That's a width of pi. So we can take this block and copy and paste it over and over again, and we would get the entire tangent graph. Okay, and that means that, for example, if we had something that looked like the tangent of b times x, its period is going to be pi over b, and not 2 pi over b. Okay, that's probably the easiest thing to forget about the tangent graph. So the period is pi, not 2 pi. So I'll put a box around that because that is an important fact to remember, a very easy fact to forget. Okay, note that when the graph exists, it's always increasing, so we don't have any relative mins or maxes. Again, in contrast to the sine and cosine graph. And one other thing we want to notice is that this tangent graph is odd. If we were to take this and flip it upside down, rotate it 180 degrees, the graph would look exactly the same. Okay, so this is an odd function, and that tells us that the tangent of -x is equal to negative the tangent of x. Okay, same as the sine graph. Okay, so those are the relevant properties of the tangent function. So now let's take a look at its cofunction, which is also its reciprocal, the cotangent function. Okay, just like sine and cosine have similar properties, okay, because of these cofunction identities, the tangent and cotangent graphs are also going to have similar properties, but they will look a little different from one another. Same way sine and cosine were not identical. Okay. So now we're going to look at the cotangent of x. Okay, remember that's cosine over sine. Okay, so now when x is equal to 0, cotangent will be 1 over 0, which is undefined. When x is pi over 4, cotangent will be 1. When x is pi over 2, cotangent will be 0 over 1 is 0. When x is 3 pi over 4, cotangent is negative 1. Negative 1 over root 2 divided by 1 over root 2. When x is pi, cotangent is negative 1 over 0 is undefined. When x is 5 pi over 4, cotangent is 1. When x is 3 pi over 2, cotangent is 0. When x is 7 pi over 4, cotangent is negative 1. And when x is 2 pi, cotangent is undefined. Okay, I went through that fairly quickly, but I just used the fact that cotangent is cosine x divided by sine x. So if you need to, please feel free to pause the video at this time and just double check my work there. Okay, so now I'm going to start out with a vertical asymptote at x equals 0, right along the y-axis. We're going to have another vertical asymptote at x equals 2 pi, and at x equals pi. At x equals pi over 2 and 3 pi over 2, y is equal to 0. So we'll have x-intercepts there. When x is pi over 4, our y value is equal to 1. When x is 3 pi over 4, our y value is negative 1. Okay, so now we see that our graph is actually going to be decreasing. It has the same general S shape as the tangent graph, but instead of going upwards, it goes downwards, because now we have to go from y equals 1 to y equals 0 to y equals negative 1. Okay, similarly, if we go on to 5 pi over 4, when x is 5 pi over 4, y is 1. When x is 7 pi over 4, y is negative 1. And so again, okay, so here's a graph of 2 periods of the cotangent function. So note, just like with the tangent, the period of the cotangent is going to be pi. So this is, again, y equals cotangent x. Period will be pi. We can take this piece between x equals 0 and x equals pi and repeat it over and over again. We see that the range is, again, all y values. So the range will be minus infinity to infinity. The domain, so now we want to avoid sine values being equal to 0. So the domain is going to be all x except for those integer multiples of pi. Okay, so 0 plus and minus pi plus and minus 2 pi and so on. Okay, so this would be the graph of the cotangent function. And finally, whenever we're graphing more complicated equations related to tangent and cotangent, we have something that's analogous to the quarter points for sine and cosine. And that is, we can take one period, remember for tangent or cotangent, the period will be pi over b and not 2 pi over b. So that period of pi over b, we can split up into quarters using 5 features. But now our 5 features will not all be points. We're going to have to start out a vertical asymptote. And then we're going to have a point at, in this case, y equals 1, x equals pi over 4. We're going to have a y-intercept, and then we're going to have another point, and then finally we're going to have another vertical asymptote. So these 5 features, now it's not 5 points, it's 2 asymptotes and 3 points. These take the role of the 5 quarter points for a sine or cosine graph. So now every period of tangent or cotangent is going to go asymptote, asymptote, so asymptote to start, asymptote to end. Halfway in between, we're going to have a point. We're going to have a midpoint. And then halfway in between each asymptote and that middle point is going to be another point. So one up here, one down here. So you figure out where your asymptotes are. In between there's going to be a point, and then in between that point and each of the asymptotes are going to be 2 more points. You plug those x values in and you get the y's, and you can connect the dots. Okay, so we'll talk about that more in a future video, but this is the analogous operation to doing quarter points for sine and cosine graphs.